sometimes it's nicer to use computational tools to help us visualize different families of curves. It's a little bit more precise than sketching it ourselves. So why don't you head on over to Desmos, and you probably already know that you can just type in some curves, x squared, x to the fourth, and you can compare them. But already I think this might be clearer than what we were doing in class. So if you look at this 0.11 over here, you can see that the blue x to the fourth curve, if we zoom way out, the blue x to the fourth curve definitely does look steeper. But if we look at the interval from 0 to 1, you'll see that the x to the fourth curve is below the x squared curve for the reason we discussed. So let me show you two things that you might not know how to do. The first one, I think you probably do. Instead of saying x squared or x to the fourth, let's say x to the n. And I'm going to click here on the left and say 2 is the smallest value I want n to have. Let's say 20 is the largest value I want n to have. And I want to go in steps of 2 because I only want to look at even powers. And so if I skip by 2 every time, I'll be sure that this exponent is always even. And so now you have this slider where you can slide it, and you see that all of the even-powered graphs have the same U-shape, but as the exponent gets higher, it becomes kind of squarer, or this kind of curvature becomes more exaggerated. So that's a thing you may or may not have known. Let me show you another thing you could do. Instead of having a slider, you can actually make a list using square brackets, and you can say, let's go from 2 up to 20. Whoops. Except I forgot we don't want to skip by 2s. So so let's do this. 4 and then 20. Maybe 20 is too many. Let's go 10. Okay. So it's figured out the intent here with this list. I said start at 2, then go to 4, ... all the way up to 10. And so Desmos has figured out that this is a list from 2 to 10, skipping by 2s. And it's now displayed all of those graphs simultaneously. And that's kind of nice because it makes it easier to compare the different graphs when they're all on the screen at the same time. Pause the video. Why don't you try for a second visualizing all of the odd powers. So try and make a list that has only odd powers from, let's say, 1 to 11. Okay, I will do it now. 1, 3, ... 11. So there you go. Maybe we shouldn't have started with 1 because y equals x to the first power is clearly just the line y equals x, this diagonal one. And you see it sort of fits the pattern of the others. It still has the same kind of symmetry, but it's like there's no curvature at all. Whereas when the exponent gets higher, it adds that curvature. So maybe it's interesting to see both ways. It's interesting to see how a line is an example of that special family. Here it looks like I'm getting both even powers and odd powers because I need to give it the first 2 to show it that I want to be skipping by 2s. Okay, so here are odd powers from 3 to 11, skipping by 2s. And again, you see the same kind of thing going on. You see that the curvature gets exaggerated the higher the degree. Let's do one last collection of families. So what about roots? In Desmos, you can type sqrt for square root. And you can see the square root. But how do you do other kinds of root besides square root? You might remember that the square root is the same thing as raising an exponent to a power of 1/2. If you wanted a fourth root, that would be power 1/4. If you wanted a sixth root, that would be power 1/6. If you wanted a third root, a cube root, then that would be power 1/3. So we'll re-review this later in the year, but for right now, I just want you to be able to experiment and visualize this for yourself. So we can do the same thing here. Let's do 1 divided by n, where n is going to go from 2 to 10, step size 2. And this is going to show me all of the even roots. So square root, fourth root, sixth root, and so on. And again, if I wanted to make this a list, I could do that. 2, 4, ... 20, 12, 14. So you can see here's the square root, and then this far more exaggerated one is the 14th root. Let's do the same thing with odd roots. So let's start with cube root, 5th root, all the way up to 11th root. And so here you can see what those roots look like. The cube root starts out with this nice curvature, but once you get up to 11th root, it looks like it's almost starting out vertically. Of course, it's not vertical. It's just very, very steep there. But hopefully this tool will help you be able to visualize the shapes better.